Hey, future tech explorers, ever wondered how we could store mountains of data in the tiniest spaces? Welcome to the revolutionary world of 3D optical data storage. Picture this. Instead of storing information on a single flat surface, what if we could store data in multiple layers within a material like a sandwich of information? That's exactly what 3D optical data storage does. It's a groundbreaking technology that uses light, specifically lasers, to store and retrieve data from multiple layers within a material. Imagine a tiny cube storing as much information as a warehouse full of traditional hard drives. It's like moving from a two-dimensional map to a three-dimensional globe, opening up a whole new world of possibilities for data storage. Intriguing, isn't it? Well, hold on to your curiosity as we delve deeper into this fascinating world. So how does this wonder of storage work? Well, it's quite a fascinating process. To begin with, we need to understand that this technology capitalizes on the three-dimensionality of a given storage medium. This medium could be a type of glass or plastic, for instance. Unlike traditional storage methods, which store data in just two dimensions, 3D optical data storage harnesses the full potential of the medium by storing data in multiple layers. Now, let's delve into the mechanics. The process involves two key players, lasers and microscopic patterns. Lasers, those beams of concentrated light we often associate with sci-fi movies, are the tools used to write and read data. When writing data, a laser is focused onto a specific point within the storage medium. This laser alters the physical or chemical structure of the medium at that point, creating a bit of data. The process forms a microscopic pattern within the medium, a pattern that can be read later on. The reading process is equally fascinating. A less intense laser beam is used to scan the medium. When this beam encounters the altered points, it gets scattered or refracted in a unique way. By analyzing the scattering or refraction, the system can interpret the data stored at that point. But here's where it gets truly mind-boggling. This process isn't limited to a single layer. By adjusting the focus of the lasers, data can be written and read from multiple layers within the medium. This is what gives 3D optical data storage its incredible capacity. Just imagine countless layers of data stacked one atop the other, all within a tiny piece of glass or plastic. So there you have it. That's how 3D optical data storage works. It's a symphony of lasers and microscopic patterns, all playing out in a tiny three-dimensional space. A dance of light and matter, etching and reading data in a way that was once the stuff of science fiction. It's a marvel of modern technology, isn't it? But why should we consider it over traditional methods? What makes 3D optical data storage superior to traditional methods? This is a question that might be bouncing around your mind, so let's dive into it. First up, let's talk about storage capacity. Traditional storage methods like hard drives and flash drives store data in two dimensions, but 3D optical data storage takes this a step further. It stores information in multiple layers within a material, utilizing the third dimension. This means that it can hold mountains of data in a relatively small space. Imagine having the entire Library of Congress in the palm of your hand. That's the kind of storage capacity we're talking about. Next, we have access times. In the digital world, speed is everything. Nobody wants to wait around while data loads. Well, with 3D optical data storage, you won't have to. Because data is stored in three dimensions, lasers can access it from multiple angles simultaneously. This results in faster access times compared to traditional storage methods. It's like having a super-fast, super-efficient librarian fetching your books for you. Finally, let's talk durability. Traditional storage methods are prone to wear and tear, and data can be lost due to physical damage. But 3D optical data storage uses robust materials, and data is written in a way that it can survive even if part of the storage medium is damaged. This means your data is not only safe, but it's also preserved for a longer period. It's like having your data engraved in stone, safe from the sands of time. But wait, there's more. 3D optical data storage is also energy efficient. Because it uses light to store and retrieve data, it consumes less power than traditional storage methods. So, not only is your data safe and accessible, but it's also stored in an environmentally friendly way. The benefits are clear, but where can we see this technology in action? Stay tuned as we explore the real-world applications of 3D optical data storage in the next scene. Now let's explore where this amazing technology is being used in the real world. 3D optical data storage is finding its place across a wide range of applications, owing to its unique ability to store colossal amounts of data in a minuscule space. One of the most significant applications is in digital archiving. Imagine the Library of Congress, home to millions of books, audio recordings, photographs, maps, and manuscripts. All of this could be stored in a space no bigger than your average coffee mug. This technology provides a secure, long-term storage solution that can withstand the test of time, unlike traditional storage mediums that degrade over time. But the applications don't stop at just archiving. 3D optical data storage is revolutionizing the healthcare industry as well. Medical data, such as patient records, imaging scans, and research data, are voluminous and increasing at an exponential rate. With this technology, hospitals and research institutions can efficiently store and retrieve these data, leading to improved patient care and breakthroughs in medical research. In the world of entertainment, think of the millions of movies, music albums, and video games that could be stored and accessed in an instant. This technology could change the way we consume media, offering faster access times and unparalleled storage capacities. The research community is also reaping the benefits of 3D optical data storage. Researchers are constantly dealing with vast amounts of data, from climate modeling to astronomical data. With this technology, they can store and access their data more efficiently, accelerating the pace of scientific discovery. Moreover, in the era of big data, businesses are continuously generating and processing vast amounts of information. 3D optical data storage provides a solution for storing these data securely and efficiently, enabling businesses to gain valuable insights and make informed decisions. Impressive, isn't it? But how does it compare to other storage technologies? How does 3D optical data storage stack up against other storage technologies? Let's take a closer look. When compared to traditional hard disk drives, 3D optical data storage shines. Hard disk drives store data on a spinning platter, a mechanical process that limits both speed and durability. With 3D optical data storage, we're dealing with light and not moving parts, drastically increasing both speed and longevity. Now, how about solid-state drives? These are faster and more durable than hard disk drives, thanks to their lack of moving parts. But they still can't match the capacity of 3D optical data storage. With the ability to store data in multiple layers within a material, 3D optical data storage can hold significantly more data in the same amount of physical space. In terms of capacity, speed, and longevity, 3D optical data storage outperforms the competition. The future looks bright for 3D optical data storage. Let's take a quick look at what's on the horizon. What can we expect from the future of 3D optical data storage? As we embark on this journey into the future, we find ourselves on the cusp of a new era in data storage. Imagine a world where we can store vast amounts of data in even smaller spaces. The future of 3D optical data storage points to higher storage densities. This means we'll be able to store even more information in the same amount of space, a revolution for industries that deal with massive amounts of data. But it's not just about storing more, it's about accessing it faster. Future advancements promise faster data transfer rates. This means we'll be able to retrieve and use our stored information more quickly and efficiently. And the most thrilling part, the future of 3D optical data storage could see an integration with emerging technologies like quantum computing. This could potentially revolutionize the way we understand and use data storage. The future is exciting, but while we wait for these developments, why not try some experiments at home? Ready to explore the principles of 3D optical data storage right in your living room? Let's dive into some exciting DIY experiments that you can do right at home. All you need are simple materials like lasers and translucent materials. First off, let's look at how lasers interact with materials. By shining a laser through a translucent material, you can observe how light is refracted and reflected. This is the same principle used in 3D optical data storage, where lasers are used to write and read data. Next, let's explore the concept of data layers. You can use a stack of translucent sheets to represent the multiple layers within a storage medium. Try writing on different sheets with a marker, and you'll see how each layer can hold unique information, similar to how data is stored in 3D optical data storage. So, there you have it, the fascinating world of 3D optical data storage. Keep exploring, keep learning, and until next time, stay curious.